All right, this is the first video of the year for pre-quizzes. So lesson one, displacement and velocity. So a vector and scalars. A scalar measurement is a measurement that only has magnitude, so it's just a number. It does not communicate direction. Examples of that would be temperature, mass, volume, and other things like that. A vector measurement is a measurement that has both magnitude and direction. So we're throwing this idea of this word of magnitude. What does that mean? That's simply the absolute value of a measurement. So no direction. It's just the number, the amount. So our first measurement is position, and position communicates the location of an object relative to a certain point, a reference point, often their origin. We measure this in meters. In physics, we try to stick to the metric system. It has a variable lowercase x, so in math classes, like the most popular variable, find x. In this case, x is used for position. So what are the positions of these two people illustrated on this number line? A has a position of -4 meters away from the origin, and person B has a position of +7 meters away from the origin. So displacement is a change in position. It's how far and in which direction you moved from an initial position. So delta, do you remember that from chemistry? That means change in. How do you calculate that? Final minus initial. That needs to be memorized. You're going to use that a lot this year. Change in, final minus initial. How do you solve for an object's displacement? Well, displacement is a change in position. So the equation we're going to use is delta x is equal to final position minus initial position. Notice the subscripts. That is not the little f and the little I stands for final and initial. It is not a variable in and of itself. It's just a little label that helps identify which position we're talking about. So distance is a measurement of something that we describe often in life, but displacement, is that the same thing? So distance measures how far an object's traveled. It communicates the total length of the path taken. Okay, so if you like go here and then come back, it's that whole distance. Versus displacement measures the change in position from the initial position. So if you started here and like went there, it would just be this part there. It communicates how far an object is away from its original location, what has actually been accomplished. So displacement communicates which way an object moves as well, where distance does not. You've heard this expression that distance can't be negative. That is true. Displacement, and we'll talk about that later. Another measurement that you probably haven't heard of is a clock reading. A clock reading is a moment in time. It's kind of an example like at what time did you enter the classroom? It's similar to a point on a number line, but it's a point on a timeline instead. So how long is a clock reading? Like how long does that last? Well, it's kind of like a moment. Okay? It's an instant, a moment in time. It's just like a point in geometry on like on a plane. It doesn't have length. Same thing with a clock reading. It doesn't have length. It's just a moment. And the variable for that is a lowercase t. A time duration or a time interval is another way to describe that, is a change in the clock reading. So the variable for that is a delta t, and the equation, as you might have guessed, is delta t is equal to final clock reading minus initial clock reading, so the time interval or time duration. Speed, we talk about that all the time. The equation for speed, you've learned that in middle school, maybe even before that, is distance divided by time. The units for that, you got lots of different miles an hour, kilometers an hour, feet per second, meters per second. Got lots of options there. How do you describe speed? How fast an object's moving, or the rate at which an object is moving. Velocity. That's interesting. The variable for that is lowercase v. The equation for average velocity is displacement over a time duration, or final position minus initial position over the final clock reading minus the initial clock reading. The textbook definition for average velocity is the rate at which position is changing. Do you see how that equation above that kind of exemplifies that? It's how quickly you're changing your position. So speed and velocity, there are some similarities, but there are some distinctions between them. Speed, we're going to use the variable cursive or script v for speed and a printed v for velocity. So speed communicates how fast something is moving, where velocity communicates how fast something is moving and which way it's going. So the direction of motion. So do you see how in physics we're going to land more on the velocity side of things because it's more describes more things. It's more informational rich or richer informationally. Distance is used to calculate the average speed, but displacement is used to calculate the average velocity. So which one of these do you think is scalar and which one's a vector? Speed is scalar, velocity is the